Hello, my name is David Rivera, and I work for Hoshizaki America. I'm also a technical advisor for Hoshizaki. Today, we're going to be talking about the KM alarms. Now we're going to talk about the one beep alarm. The one beep alarm means that the evaporator reached 127 degrees during harvest. In other words, the evaporator got too hot. We need to confirm that the hot gas valve is opening. We need to make sure that it's energizing. We need to make sure that the thermistor is not shorted out. And we also need to make sure that we don't have hot water migration coming to the machine. Hot water migration is one of the things most difficult to diagnose on that machine, because you'd have to be there for the next 7 days until it faults out, temping the water. To be able to confirm that we have hot water coming into the machine, on the back side of the unit where the water line meets the machine, there's always a brass fitting. We're going to put a little dab of Vaseline on the top. We're going to go through the list and confirm that all the other items on that machine are working properly. When the alarm comes back, I want you to first check that little blob of Vaseline that you left on the brass piece on the back side of the unit. If it melted off and it fell on the floor, that means that you have warmer than 92.5 degrees of water coming into the machine. Vaseline has a melting point of 92.5. Now we're going to talk about the two beep alarm. The two beep alarm means that the machine ran a long harvest 2 times in a row. To be considered a long harvest, the machine has to run that harvest for 20 minutes. Let's talk about the things that could cause this long harvest. We need to check the thermistor and make sure that it's reading properly. We need to make sure that the hot gas valve is energized and there's refrigerant flowing through there. We also need to make sure that the TXV and the liquid line valve is not leaking by. We also need to make sure that there is not an inefficient compressor. Now, there's 2 things that we're looking for an inefficient compressor. We're looking for equalized pressures and low amps. If we're working on a water-cooled machine, we need to confirm that the water regulator is not leaking by. If the machine is turned off, the water regulator shouldn't be leaking by. Now let's talk about the 3 beep alarm. The 3 beep alarm is a long free cycle 2 times in a row. To be considered a long free cycle, the machine has to run a 50 to a 60-minute free cycle. The things that could cause this are if the float switch is stuck in the closed position, if the water valve is leaking by, if the hot gas valve is leaking by during the free cycle, if the pump motor stops running, if the TXVs are not feeding properly, if the liquid line valve is not flowing refrigerant, and if the machine has a headmaster, it could be bypassing. We need to confirm that the charge is correct before you confirm that the headmaster is bad. An inefficient compressor could also cause this problem. Now we're going to talk about beeps number 6 and 7. There are low voltage and high voltage alarm. First, when you have this alarm, the first thing we're going to do is we're going to go straight to the K2 connector, because that's where the board gets power. We're going to confirm that we have 10.5 volts. The transformer that's inside of the control box, if we have 115 volts going into it, it's going to push out 10.5. But if the voltage is a little bit lower, like 90 volts, then the transformer is not capable of pushing out 10.5. You're going to push out something a little bit lower, like about 7.3 or 8.5. That's going to be too low, so the board is automatically going to go off on that 6 beep alarm, which is a low voltage alarm. The 7 beep alarm is a high voltage alarm. If the voltage coming into the transformer is higher than 115, like let's say it's 130, then the transformer is not capable of pushing out 10.5 volts. It's going to push out something a little bit higher, like 13, maybe 14 volts. So when you have this alarm, first thing we need to do is confirm the voltage at the board on the K2 connector. Then we're going to check the voltage going into the transformer. And that's how we're going to correct the problem.